Hey everybody, in today's lesson we're going to start with the introduction to linear inequalities. Now to do this we're going to first look at the different symbols and writing down exactly what each symbol means. So you should have seen these symbols before, but just in case you've forgotten, we're going to go through what exactly each symbol means. Now the equal sign is going to mean equals to. The symbol that is opening up to the right is going to mean less than. The symbol that is opening up to the left is going to be greater than. And the symbol opening up to the right with a line underneath it is going to be less than or equal to. So that line underneath, so this line right here, allows it to also be equal to that number you're talking about or less than it. And the last one, where it's opening up to the left and has a line underneath, is going to be greater than or equal to. So notice that this symbol and this symbol are the same, and this symbol and this symbol are the same. The only difference is that the line underneath them allows them to be equal to the number you're talking about. So let's take a look at this. If we're looking at these symbols that you've probably seen around before, so these are kind of real life situations, just as the speed limit is 55, this is going to mean that you're allowed to go 55 or equal to that, but you can't go above this. So you want to go less than 55 or equal to that, but you can't exceed 55. If we're looking at PG 14A, well, 14 is going to be a number that we're working with. And if it's a PG 14A, it means you have to be older or equal to 14. So you have to be the age of 14 or older to be able to watch that movie. So it means you got to be greater than or equal to 14. So when you're looking at something that is going to be more than 14, it is opening up away from it. And if you're looking at something that is going to be less than 55, so less than a certain number, it is opening up towards it. In the other one in the top right here, it says the height restriction. You must be at least 102 centimeters to go on this ride. Well, if you have to be at least 102 centimeters, 102 centimeters is what we're working with, and you have to be greater than or equal to, because it says at least. So you're going to have your line underneath and it's opening up away from your 102. And this last one here, it says store at temperatures below 4 degrees Celsius. So 4 degrees Celsius is the number that we're working with. And it has to be below, so it's going to be less than. So it's opening up towards. Not going to have an underline under the symbol because it has to be below. It cannot be equal to that amount. Now we'll flip over to the next page and we're going to be looking at example 1. So example 1 says write an inequality to describe a situation. Define a variable and write an inequality to describe each situation. A says contest entrants must be at least 18 years old. So 18 is the number we're going to be working with, and they must be at least 18 years old. So you want to be over 18, but you can also be equal to 18. So it's opening up away from it with the underline. B says the temperature has been below -5 degrees Celsius for the last week. So -5 degrees Celsius is what we're working with. and it says it has been below -5. So that means it's opening up towards, because it's been less than -5, but we would not put the underline because it's not equal to, it's been below -5, not equal to -5. Now for C and D, I'm going to leave for you to complete. Please check the OneNote once you've done them to make sure you've done them correctly. In example 2, determining whether a number is a solution of an inequality. A says consider x is greater than or equal to -4. Which number is part of the solution? To help you out, I'm just going to draw a quick number line over here, and we have 0 in the middle, -4 over here, and we want a number that is greater than or equal to -4. So it's anything that's to the right of -4 here. So -8 is not going to work. -3.5 would work. -4 would work because of this underline. And -4.5 would not work because it is less than -4. Last 0 would work because it is greater than -4. For B, it says consider x is, now this is going to be less than 9. Which number would be part of the solution? So look at the numbers below. So 17, 0, -2, 9, and 12. And I'm going to leave this one for you to complete. And remember, you're looking at something that is going to be less than 9. For example 3, we're going to look at now graphing inequalities on a number line. When graphing inequalities on a number line, a solid dot will indicate inclusions of that point, and a hollow dot or a hole will indicate a non-inclusion of that point. So that means anything with the underline on it is going to be a solid dot, and anything that is greater than or less than but not equal to will be an open dot. So if we're looking at the examples below, it says now give the inequality for each number line below. The starting point would be looking at what number are we talking about. Well, it's where the dot or the open dot is. We're right on 0, so 0 is going to be where we're starting. Now, it is a closed dot. If we look up here, a closed dot means that it can be equal to. So we want a number that is going to have a line underneath it. Or sorry, a symbol that's going to have a line underneath it. The next thing we have to determine is it greater than or is it less than? Well, it's going to the left, which is going further negative. So we're going below 0, which means it's going to be less than 0. So it is opening up towards it. For B, we first look at our number, and it is -2. So -2, and it is an open dot, meaning that it's not going to have a line underneath the symbol. And the next thing we have to decide is it less than or is it greater than? Well, it's going to the right, meaning that it is going to be greater than that number because it's increasing. So it's going to be opening up away from it. So it's going to open up to the left, and then it's -2. For C and D, I'm going to leave for you to complete. Pay attention to it's an open dot or a closed dot, and then think about the direction that it's going. Is it going to be greater than or less than that number? Now we'll look at showing the solution for each inequality on a number line. So this time, instead of being given the number line, we're going to be creating the number line to get a good understanding of how to write this down. What I started off with doing is first creating the number lines for the questions that I'm going to do for you here. So I just did a simple number line with an arrow on each side and then just made approximate spaces and numbered it positive and negative. Now, what we do is we're looking at the inequality that's on the left here. So first thing I want to think about is the number. Where am I going to be? Well, I'm looking for 4. So 4 is going to be right over here. The next thing I have to think about is this going to be an open dot or a closed dot? Well, we know a closed dot is one that has the line underneath. If it's one where it doesn't have a line underneath, it's going to be an open dot. So for this one here, we have a line underneath, meaning that we can put down a closed dot. So this closed dot is going to go right over top of my 4. The next thing I have to look at is it going to be greater than or less than? If it's opening up towards the variable, it means that it is greater than, and if it's opening up towards the number, it means it is less than. Now, this may get difficult to actually show up, so I'm going to show it with a different color just to help make it more visible. Now, you could also do it above the number line if that is easier. So I have x is greater than or equal to 4. So I'm going to go to the right and put an arrow, meaning it's anything that is going to be greater than 4. For b, I have n, and then it's opening up towards 3, so that means n is less than 3. And there's no line underneath, meaning that it's going to be an open dot. So if I do an open dot, and it's going to be less than, and I just write my arrow at the end of that line. For c, you have x, and then it's opening up towards -2 with a line underneath, meaning that x is less than or equal to -2. So we have -2, and it can be equal to it. So we're going to do a closed dot, and then it's going to be less than, so it is going to be pointing to the left. Now, if you notice too, if you have it set up with the variable on the left-hand side, whatever way that is pointing, you could think of that as your arrow, and that is telling you which way that line is going. But that is only if your variable is on the left-hand side. Now, I'm going to leave D and E for you to complete on your own. So make your number line, and then think about, is there a line underneath your greater than or less than symbol? If there is a line, it's going to be a closed dot. And then pay attention to, is your variable on the left or the right? That's going to help you determine, is it greater than or less than? If it's opening up towards the number, then it is less than. If it's opening up towards the variable, then it is greater than. Here it says, note, when the same number is added to or subtracted from each side of an inequality, the resulting inequality is still true. Now, what that means is, if we had, for example, 3 is less than 7, and we added the same number to both sides, so we added +1 to both sides, or we subtracted 6 from both sides, what we're talking about is 3 subtract 6 is less than 7 subtract 6, meaning you have -3 is less than 1, or you could think of the other one where we have 3 plus 1 is less than 7 plus 1, so 3 plus 1 is 4, is less than 7 plus 1, which is 8. So it still stays true if you add or subtract the same amount from both sides. At the bottom here it says, but when we multiply or divide on both sides, the resulting inequality is not always true. So that's the difference here. When we're talking about adding or subtracting, the resulting inequality is still true. when we're multiplying or dividing, the resulting inequality is not always true. So when we're doing multiplication and division, it can change the way that the symbol is facing. So this first one says, now multiply both sides by 2. So we have 8 is greater than 3. If we multiply both sides by 2, we have 8 times 2, which is 16, is greater than 3 times 2, which is 6. So this is still true. But the next one says 8 is greater than 3. Now multiply both sides by negative 2. So we have to multiply it by negative 2 and negative 2. So we have 8 multiplied by negative 2, which is negative 16. And 3 multiplied by negative 2, which is negative 6. So our symbol is not correct anymore. So when we're multiplying by a negative number, we have to switch the direction the symbol is facing. So it's not always going to be true when we're multiplying and dividing. Now, to overcome this, follow the following properties of inequalities. When each side of an inequality is multiplied or divided by the same positive number, the resulting inequality is still true. So the same positive number, the resulting inequality is still true. And this is for multiplying and dividing. When each side of the inequality is multiplied or divided by the same negative number, the inequality sign must be reversed for the inequality to remain true. So when you're multiplying or dividing by the same negative number, the inequality sign must be reversed. So that's important. Whenever you're multiplying or dividing by a negative number, you have to reverse the inequality symbol. Exactly what we did on the other page when we had 8 is greater than 3, but multiplied it by a negative 2, we flipped the inequality so that we had negative 16 is less than negative 6. So we flipped over that inequality. Now, we have to work on the ones below, and it says to show the solution on a number line. Before I do the number line, I want to change something in this inequality. I have negative x is greater than or equal to 4. What I want to do, though, is have my variable always being positive. The way that I'm going to do that is I'm going to divide this by negative 1, and you have to do it to both sides. So divide both sides by negative 1, which will change that negative and get rid of it. So it's going to get just x. And remember, when we're dividing or multiplying by a negative number, we have to flip that symbol. So it's going to flip over, and we're now going to have negative 4. So what this means is we used to have negative x is greater than or equal to 4, and now we have x is less than or equal to negative 4. I'm going to do a rough sketch of just the number line, so I'm going to put a line and a dash, and I'm going to write my negative 4, which is my number that I'm working with. Next thing I'm going to think about is there going to be a closed dot or an open? So is it going to be filled in or left open? Well, I can be equal to this number, so I'm going to fill in that dot. And then I have to decide, is my arrow going to the left or to the right? Well, x is less than or equal to, so it's going to go to the left, and I'm going to put my arrow facing that way. It's important that you make it an arrow because it can be any number that is less than or equal to that. Looking at G, I again have the same problem. I have negative x and I want that to be a positive. So I'm going to divide by negative 1, divide by negative 1, making this x, flipping the symbol, and keeping, now, there isn't an underline, so don't add an underline. And then we have 3. Number stays the same, but it becomes negative because I'm dividing by negative 1. So now what I have is x is greater than -3. So I'm going to do my rough sketch of a number line and draw 3 down, sorry, -3 down. And the first thing I need to think about is this going to be an open dot or a closed dot? Well, there's no line underneath my greater than or less than symbol, so it's going to be an open dot. And then I gotta write my arrow down. Well, this is going to be x is greater than -3, so it's greater than, I'm going to the right, and it's going to be pointing that way. Now we have h, and we have -2 is less than or equal to -x. So again, you have to get rid of that x. You have 8 is greater than or equal to -x. And again, you have to get rid of that negative on that x, so divide by -1. So I'm going to leave these two examples for you to complete, and please check the class OneNote when you have completed these questions. If you have any questions about this, please send me a message on Teams or ask me in class the next time you see me. Have a good day.